Hey guys, welcome to another video. Today we continue on with the nice questions series of videos. If you haven't already done so, please subscribe to the channel, like the video, tell your friends. Today's question comes from the Extension 1 syllabus from St. George Girls 2022 paper. It's on the topic of volumes under the calculus integration topic. Let's get stuck in. So for 4 marks, now just reading through this, a carpenter is using a lathe to create part of a small wooden bowl, right? So it's creating a small wooden bowl. You can see they're in the blue, 10 centimeters tall, 8 centimeters wide. The shape is formed by rotating about between those two curves and the y-axis. So how do we do this? Now, it's quite important, right? Firstly, let's highlight the two functions at play here. So that one there, that one there. So it looks like one's on the outside, the sine curves on the outside, and the parabola is on the inside. Yeah, and we're rotating from 0 to 4 on the x. Cool. About the y-axis, that's super key. So we're rotating about this axis, right? What that means is that when we use a formula, so obviously we're going to take a difference, right? So generally speaking, right, if I had any formula, so any function, right, any function, let's say, I don't know, some function like, I'll make it like this, right? Oops. Like that, right? So y equals to fx. And I wanted to rotate it about the y, right? Yeah. The formula for this would be volume equals to pi from a to b, limits of a to b, might be a there and b there, right? And it's x squared dy, right? That's really the formula at play here, right? That's the one I care about. So for this one here, I just have to do it twice and then subtract it. Because they all eventually have the same limits, right? I can combine them or separate them, whatever you do. Actually, it's the same limits, right? Yep. So, okay. So what I'm going to do, yeah. So it's always the same limits. Yep. Okay. Maybe cutting off there. So for the first one, maybe from 0 to 10, and then the other one from 0 to, so from whatever that is to 10. So, okay. So I'll deal with the parabola first, right? I'll deal with the parabola first. Yeah. So from the parabola goes from, now I can see there, y-intercept is 2 to 10, right? So for the parabola, right, I'll maybe sneakily color this in pink. Oh, yeah. The volume of that is pi from 2 to 10. Yeah, from 2 to 10. No, actually, is it 2 to 10? So I still got it. Yeah, I think it's about the same. 2 to 10, and then it's x squared dy. Now, I just need to make x squared the subject. So for this one here, right, to make this guy x squared, so come down here, and what's that? X squared would equal to minus the 2 over, and double it, right? I'm going to sub that in, right? So plugging this guy into here, right? I don't need to make x a subject, just x squared would do, right? So that would give me pi 210 of, I'll expand that, so it'd be 2y minus 4 dy. Yeah. So that would give me, let's see, pi, integrate that, becomes y squared minus 4y with the limits of 10 and 2. Sub that in. Pi, what's that? 10 squared and minus 4 times 10 minus 2 squared minus 4 times 2. Yeah. Now, calculator, minus 40 minus 4 minus 8. Yeah. So I got 64 pi. Yeah, 64 pi. That's my parabola, right? Now, the blue one on the outside, I need to then go, so if the pink is the thing that I'm inside, right? So that's going to be the thing I'm going to minus. I'll park that to the side now. For the blue, once again, pi the limit now is from 0 to 10, right, of x squared dx. So dy. Now this one here, this is the formula here, right? So I got to basically make x a subject here. So what do I do? Times, so I got sine inverse of x on 4 equals to pi times y on 20. And then x equals to 4 times sine of pi on 20y. Okay, cool. So that's what I sub in, right? So 0 to 10, 4 sine. It just looks nasty, right? It just looks nasty, but it's actually not that bad. It's just sine squared, integral of sine squared, right? So if you're comfortable with that, so let's drag out all our constants. So that's right there. That's all squared. So that's 16 pi. Sub 0, 10. That's sine squared pi on 20y. Now, please recall, right? And I might move this further to the right, just to give me space to do this little mini recollection, right? Please recall, whenever you try to integrate sine squared, right? We know that sine squared theta equals to 1 minus cos double angle on 2, right? So I'm just going to replace that into there. So that becomes 16 pi 0, 10, 1 minus cos. Double of this guy would be pi on 10y all over 2 dy. The 2 and the 16 cancel out. Give me 8, right? And I'll be integrating that. So it'll be like 8 pi integral of y minus, now integrate that, becomes integral cos is positive sine pi on 10y divided by pi on 10. Yeah, divided by pi on 10. The limits of 10 and 0. Should I clean this up? Put the 10 upstairs then? Maybe not. Right, let's just do it. Right, let's just be amazing. So 10 minus, now I'll go 10 on pi, right? So 10 on pi times sine times 10 in that sine pi minus, okay, the sine's good because they cancel out, right? Minus 0 minus 10 on pi sine 0. Great. Perfect. That's perfect because I know that sine pi is 0. I know that sine 0 is 0. So everything, all these guys go away, right? That guy goes, that guy goes, that guy goes. So it's just 8 times 80 pi. Yeah. So guys, hopefully that was okay, right? That's just integration. So your answer is going to be blue minus pink, right, in terms of volume. So therefore, right, I'll do it down here. Therefore, volume equals to 80 pi minus 64 pi, right, which is 16 pi units cubed. Guys, how was that? It's a nice little question, right? Just made it a little bit complicated with the sine inverse, but you just have to make x a subject. Once you do that for the blue, obviously I did the pink first because it was easier, right? With the parabola, hammer that out. And then once you do blue and pink, take the subtraction, that's your volume. Guys, if you like that video, once again, please tell your friends, subscribe to the channel, and I'll see you at the next video. Thank you.